Ladies and gentlemen, please welcome our next speaker, Roy Wasse, presenting the topic, the definitive answer to measuring developer productivity.
So I'm standing between you and the drinks, so thanks for showing up on the last talk of the day. I'm going to talk about a subject that I think many people here probably have an opinion about. How to measure developer productivity, how to determine skill level of a developer. These are questions that are not straightforward to ask, and everybody has, well, ways maybe to test this. And we're going to talk about some ways that we can maybe do this in a better way. So who am I? I put some background up in the slide here. Once upon a time, long ago, I studied computer science. Then I studied philosophy of technology with a specialization in AI. Started working as a developer at a consultancy company, a daughter company of Capgemini. Worked there for a number of years. Became an engineering manager, but always kept track of what was going on in the Java space, especially. Was a jug leader for many years. And started my own company together with a co-founder in 2017. It's called Open Value, and I've been doing lots of hiring in that period. Worked together with lots of developers also. So I also had a lot of opinions about this subject, and I'm sure that you also have like tricks to determine how good somebody may be, how well of a fit somebody might be for your team. And I have a few of these on the slide. So maybe you ask, like, are they familiar with acronyms that are used a lot in the industry, like you aren't gonna need it, or hypermedia as the engine of state, and so on. And you want to make sure that people are familiar with those. Maybe you think it's important that they understand certain algorithms. I used to work with a CTO back in the days. If you didn't get an answer right about how to implement a binary tree search algorithm, he would stop the interview there. So that was kind of harsh. So yeah, I don't know if that actually was a good idea. Probably not, because some people were let go at that moment who I thought had a great background and maybe could really add something to the company. Maybe you just go to the internet and see what other people are asking in a technical interview. Maybe that works for you. But maybe somebody that's then taken the interview has read the answers there as well. So maybe not a really genius idea. Then there's this more wild idea of open hiring. I don't know who is familiar with that, but the idea is that we all have biases, and you want to prevent your bias from hiring the right kind of person. So what you do, you just put out a job posting, and you say anybody can start on this job. And then after like a week or two, you see how somebody is doing. And if you're both satisfied, well, you turn the probation period into a contract. So it's pretty wild, and I'm not sure that I would want to do that. But the funny thing is, I ran into a company that's actually doing this in the space of software engineering a while back. I must say they were doing this with more the junior profiles, and it worked well for them, she said. Okay. Then I think what most people do is that they use proxy variables as well in the selection process. And you look at somebody's CV, their prior experiences, educational background, references from other people. Maybe you let them do some questionnaires online, etc., and you get some insights from that. So these might all be good ideas. Oh, that's of course the whiteboard coding, a really important one, I think. That's a good way to test how somebody can perform under stress. If you're in a job interview, you need to write some code on the whiteboard. There's a lot of stress at that moment, and if you can perform really well then without your IDE, the normal environment in which you're normally writing code, well, that says more about how you can handle stress maybe than about anything else, in my opinion. So it's a tricky way, I think, to select anyone. And then there's the lengthy assignments. Maybe you have like a homework assignment that you ask someone to do that can maybe sometimes take up like 2 or 3 days. And then you need to be lucky enough that somebody's willing to complete that assignment for you, and that is not going to maybe a competitor that has a more streamlined hiring process. So I saw a customer of ours, and they have been using the same assignment for a number of years, and there are multiple answers for that assignment on GitHub. So also a little bit tricky, and who says that what's in the assignment is actually the right thing to measure? So a lot of questions around that as well. So you can also look at Google. How's Google doing it? Well, they're basically doing everything that was on the previous slide. So they have a couple of interviews online to see what your motivation is, how the fit could potentially be, what your background is. Then you need to do like an assignment. Then you need to complete a small project. And if you go through all that, then you get a rounds of interviews. So that's a lot. And I don't think a lot of companies can afford to do all these kinds of things. And is it actually really needed? Because who knows what actually works? And what's really interesting is that there's actually a bunch of research around this subject. And I ran into this after I contacted a guy at the Oslo University called Gunnar Bergersen, who basically dedicated his entire career to measuring developer productivity. And I went into his PhD and I read it and I saw some references and I learned a lot. And from those papers, I read other papers and I got quite a few interesting insights from all of that. And I want to share some of the things that I found out. So first, the use of aptitude tests. So a test that somebody takes online. Hey, maybe you need to solve some puzzles there. And it's supposed to say something about your potential fit for a development role. Well, since the 70s, it's already known that these aptitude tests don't really work. And companies have been using them for a long while. Even when I started my career, I needed to do an aptitude test. And I know for a fact that based on the outcome of the test, you were either giving, no job offer, a job offer as a test engineer, or a job offer as a development engineer or dev engineer. So that's pretty wild, I would say. There's an interesting study done in the 90s where a group of students was asked to do either the general aptitude test for the United States Air Force or a specialized test that should be really good at selecting developers. And it turned out that both these tests worked equally well and that the predictive value of those tests was almost zero. So better think again if you want to use an aptitude test in your selection process or if you want to measure developer productivity and so on. So I got a question for you. So who here thinks it's really important to have a computer science background if you're going to be in a role as a software engineer? So please raise your hand if you think it's important. Well, I think about 20% of the people raised their hand. And I, for one, said for many years in my, well, I would say long career, I'm getting a bit old, I thought that for a long time. It's really important to understand how the fundamentals under the hood work, because then you're a better problem solver and so on. I would use this argument all the time. But then I worked together with a lot of really good software engineers, architects and so on, who studied like philosophy or physics or, well, something that had nothing to do with computer science. So I changed my opinion a bit. And there's actually a study around the subject that shows this as well. So a large meta study that was being done showed that shortly after graduation, there's some correlation between job performance of a developer and their educational background, computer science study. But after a few years, it's almost zero, the correlation. 0.05 is, well, equal to there's no real correlation between a computer science background and job performance. So it doesn't make any sense, according to this piece of research, to ask for a computer science degree if you're also asking for like 5 years of experience in the field. So that's something that you can take away. Another question then. How important is that experience then? Who thinks that a senior developer should have at least 5 years of industry experience? Again, raise your hand. Well, it's a bit hard to see. It's a bit more than the other question. I would say almost half of you. So at least 5 years of experience before you can call yourself a senior. So let's again look at a few research papers actually around this subject. And surely there's a positive effect of having prior programming experience and job performance. And that was also being researched. But beyond the first few years, there's actually no real effect of experience according to two different studies. So think about that. After a few years, it doesn't really matter if you have 4 years of experience or 8 years of experience and so on. And I think if you're honest, you can maybe recognize this. So for me, this was also a little bit of an eye-opener. But if you look at, well, the really smart guys that you work with, smart girls that you work with, and you take into account how many years of experience they had. Well, sometimes somebody is really, really good after just a year, 2 years, 3 years. And sometimes you work with somebody who have had like 10 years of experience, but they don't bring something extra to the table, in your opinion. So also, again, if you are searching for a new team member, maybe not necessarily think about at least 5 years of experience, because you're going to miss out on some people who might have been a really good fit. And it's probably not something that you want to do in this market. Okay, then my last question. Who here thinks that Gen AI is going to replace us as developers within the next few years for the better part of our job? I see 1, 2, 3, 4. I see 4 hands, so that's really cool. So would be a nice topic to chat about during the drinks for sure. So I don't know the answer to that, but I do know that it has some impact on us as developers for sure. There's an interesting paper called Refactoring versus Refactoring from the beginning of this year. And what that paper basically says is that it's becoming harder to progress, well, basically from a junior to a medium to a senior developer due to these LLMs. And I think it makes a lot of sense. If you want to be really good in software development, learning details matter. If you want to be good at writing regular expressions, well, you better do a lot of practice. But if you don't do it that often, you probably go to ChatGPT and you ask, please write me this regex, right? And this goes the same for if you want to work, maybe you don't regularly work with PLSQL and you just ask ChatGPT to generate the query for you. Then you don't really learn it, right? So this can be a problem there. And the question is also, for whom is it ideal? Is it ideal for a junior? Well, that's the question. It can help and coach maybe the junior, but can also prevent them from learning the details, as just mentioned. For a mediator, it can be a really handy tool. And a senior usually already knows the kind of output that Gen AI gives you. So that's a bit about the role of LLMs. Oh, I got one more question. That's right. We have certification in our field. So the question is certification important for a developer? Should you have the proper certification if you're maybe working as a .NET developer or a Java developer? Who thinks that's the case? This is really great. Just one hand. I love this. I totally agree. So being able to write software is a skill. Knowing how to do it and not knowing what to type in. It's not about the factual knowledge. It's not about knowing what's in the API. It's not about being able to spell out what the compiler does. It's something that you internalize. It's more like a holistic thing that you acquire over time, like learning how to ride a bike. You can read the manual about how to ride a bike, but you need to practice. And I think the same goes for coding. But nonetheless, it turns out that having the right knowledge is a really strong predictor, a central predictor, as Chi says in his paper 1998, for how well you will be performing as a developer. So maybe therefore, if somebody puts on a lot of programming certifications on his or her CV, it does say something, probably. So that's also interesting. So I talked about a skill. So what is a skill? A skill is an ability, something a person can do, like maybe winking your eye. But no matter how much you practice, you can either wink your eye or you can't. It's not something you can really improve upon in time. A skill is a special type of ability. It's something that you can actually improve over in time by practicing. And there's a nice model here that I actually used in my graduation assignment back in the days that you can use to measure skill level. And this is also something that's really interesting for our subject today, of course. And this model is being created by drivers and drivers. It says there are 5 different levels that you can go through, from beginner to expert, from novice to master. And you can think about this level as follows. If you want to learn how to drive a car, you start out as a novice and you need to understand where the steering wheel is, where the clutch is, how to shift gears, and you need to actively think about how to do all these steps. and you try to internalize it as good as you can. And the first time you try to drive away with the car, well, the engine turns off. You practice a bit more and you get used to the procedures. You understand, put the clutch down, shift gears, gently let the clutch go, put down the gas, and you practice and you know the procedures by heart, but it's really hard to get it right and get the timing in a good way. But at a certain point in time, it becomes more easy and you go from competent to proficient. If you're proficient, you still need to actively think about what you're doing, but you learn how to, well, brake in time before you turn the corner, uh, and so on. And a certain moment in time, you know, it becomes more automatic. You're no longer actively thinking about it. It's more shifting to your procedural memory. And you can even maybe talk to somebody sitting next to you while driving through a busy city center. Then you have become an expert. And some people can progress to the next level and they become a true master. So think about maybe a Formula One driver that can drive very, very fast through corners and talk on the radio at the same time. Think about a guy that you know that drives into his garage at a high speed and stops the car 1 centimeter before the wall. And it's costing him, well, so it seems, no effort at all. And it would be great if we would, could be working with developers who also reach this master level. And I think maybe if you ever experienced flow while writing code, you may be operating at the master level. You're no longer actively thinking about the programming constructs that you're going to use. You're just reading specifications, or you're thinking about the problem you're trying to solve. You're not really thinking about how to actually use your IDE. You're just using the shortcuts that you have internalized, and you're actively thinking about the problem and you're typing the solution at the same time. This is a great feeling, and it would be great if you can, well, work in that state the whole day with others that also have that state. So it would be good if we can find people who have that high skill level. Or is there more to it? Do we need to take more things into account? Something was also mentioned in the keynote this morning. What about soft skills? Well, yeah, I think it's definitely important. But let's also, again, look a bit about some research around this subject. So first of all, you cannot say somebody's really skilled, so there will be good performance. Research from Campbell, McCloy, and Opler and Zaker says you also have things like knowledge and motivation. So if you're not motivated, well, nothing's going to happen, right? And if you don't have any knowledge, the same thing. Campbell says there are 8 different dimensions that determines how well somebody will perform in a certain job. And depending on the type of job, some of these factors are more or less important. Okay, 8 different things, and skill is just one of them. Okay, well, maybe not that important then. Well, McGill looked into the study of Campbell and looked specifically at which of these dimensions are most important for a software developer. And in his paper he says technical skill is definitely the most important one of all those factors. Okay, so maybe do focus on that a bit. Then there's another interesting study done by Jurgensen. He investigated almost 5 million bits that were being done on approximately 800 projects that were being put there by clients. And service providers could do a bit, and he looked at the project results that were executed by these service providers that won the bits, and he found out that if the service provider would have a lower skill set and if he would also offer the lower price, there was a 9% increase in failure rate. So there's some correlation there as well directly between the skill level of a service provider and the success of a project. All nice, we're talking about individual developers here, but what about teamwork? Isn't it about how well you fit into a team? Well, it turns out that it's actually quite hard to measure team performance. It's not so easy to say what makes it up. There's a complex combination of factors that are influencing each other. But according to Lang, Wong, and Jeffrey, individual skill level of a team member is a central predictor to team performance. Okay. Again, skill is actually very important to say something about the productivity, even inside a team. And there's a bunch of other research mentioned here that basically say the same thing. So A famous book by Boehm. He looked at many different projects and he said that the people factor in any software development project is the most important predictor of success, and that the developer attributes of those people are the best predictor for, well, improving the software productivity. There's also a study that looked at technology stacks that were being used, and it turned out it doesn't really matter if you build your software project with Java, .NET, or even PHP. I was a bit disappointed by that, being having a Java background, but it is what the study says. So it's more about the skill level than about the stack, for instance. A small sidestep. It turned out that pair programming is also a nice way to boost productivity. But what we usually do, at least what I see a lot as well, is that you pair a junior with a senior to get the junior up to speed. But it turns out that if you match people who have equal skill level, that pair programming gives the best results. So that's maybe something you can think about if you do pair programming in your project. You know, and it's a lot of this what I'm telling you, not just also common sense. The US Bureau of Labor Statistics, they actually got it right, I would say, in their definition of a software developer. It's someone who usually holds a bachelor degree in computer science, so knowledge is important, it is a central predictor, right? And has strong computer programming skills. Again, it's about skills. So why not hire based on skill level? And if you're a developer and you want to, well, progress, maybe it would be really nice to know what your current skill level is and how you can improve the skill level. So this is where the work of Gunnar comes in again. So a lot of the things I just told you, you can find some references to it in his PhD study. And he wrote this in 2015. And after this, he went on to create a platform that incorporated a lot of the insights I just shared with you. And now it's going to get a bit more interesting. So this is some of the work that Gunnar published. You can look it up at Google Scholar. And these are specific papers that he wrote, well, basically because he needed to do some research for the platform that he wanted to build. And he needed to understand how he can measure skill in an objective way. We talked about a few approaches already, the homework assignment, the whiteboard coding, and online questionnaires. Well, there are some issues with that, and I would say they're definitely subjective. I mean, who determines that a specific whiteboard coding assignment is the best way to determine the skill level of a developer that you want to work with? So we need something more objective, or at least backed by research. One of the things that Gunnar could use is the Dunning-Kruger effect. You probably heard about this effect. It's about, the idea is that if you ask somebody, how good do you think you're going to perform at any given task? People tend to rate themselves too high. Unless they're an expert, then they tend to rate themselves a bit too low. But normally, people rate themselves a bit too high. But if you ask the same person, how well do you think your peer is going to say that you're going to perform on that same task? They tend to rate themselves more fairly. But that's an interesting effect, something that Gunnar could use in a way to somehow determine the skill level of a group of developers. And he looked into specific research about measuring skill level. And he saw that it was started already in the 1950s. People wanted to understand which traits of punch card operators made them stand out. There were huge productivity differences. And in the 60s it went on, and in the 70s a lot of papers were published. And there's actually a nice meta-study that looks at 20 different papers. And they basically have kind of the same insight. If you want to say something about productivity, developer productivity, and you want to have like an objective way to measure that, you need to look at specific tasks. Not just any task, but a task that a person does in the normal day job, in the environment that they're also normally using. So in our case, that would be our regular IDE on our regular operating system that we're using, and the task should be about something that you also normally do in practice. So probably that's not implementing Dijkstra's search algorithm, right? I don't think too many people do that on a daily basis. It's more like solving a bug, integrating something, and so on. So the task should also be about those kinds of things. So again, something that Gunnar could use. He found an interesting study done in the 80s around Lisp. Who here has worked with Lisp? Nobody. Oh, one guy. Yeah. So Lisp has I never did any Lisp, but apparently Lisp has a limited amount of way that you can solve a problem. Around 30 different ways to solve different kind of programming problems that you usually encounter. And this study found out that if you are really good in solving certain problems with strategy A, B, and C, it says a lot about how you're going to perform in D, E, and F. So you need to find the right kind of tasks in a given programming language and find the common problems. Then you can say something predictive about other tasks in the same programming language. So with that idea, Gunnar now needed to do a few extra things to be able to create a system to measure skills in an objective way. He wanted to incorporate the factor of time. If you ask somebody to take a test, you want time to be a factor, otherwise you can wait forever maybe. So he did some research around that. He also used some research from Ebert around how to measure quality of software. So there's even an ISO standard for software quality, and he could use a lot of those insights as well. So he could use that to see if the code that was being delivered was of the right quality. And then he needed to understand what the right kind of tasks were, and he used research from DIBA for that. So next step, he needed to have some kind of model that he could use to score different tasks, and he used the Rush model for that. It's actually a quite popular model in sciences that try to understand how the brain works, how to measure reading performance, for instance. It has been used for a long time already, and he thought I can use also the same thing for measuring measuring how well somebody wrote a piece of code. So now he picked some existing tasks from literature. He reanalyzed those data sets based on the additional research that he did for time and quality. And now he needed to create like a control group. And the nice thing here is that he actually got a subsidy of almost €500,000. And he used that to hire developers, basically from different countries, from different skill levels. And he used that group to bootstrap the model. So he used the Dunning-Kruger effect to initially score the developers. He asked them to do different tasks. They manually reviewed that. They tried to determine what the proper solutions were, and then determined how well people did the task. And that bootstrapped the model. And this platform is actually online nowadays. It's called GRAPS, Measure and Analyze Software Engineering Skills. And if you take a test on the platform, you get an outcome like this. You see how you scored compared to other people that did a test on the platform as well. Now, the first person scored around a 7, which is quite a high score, I can say. And you can also see that he performed really well on the axis of object orientation and refactoring. You also have unit testing there, coding speed, implementation, and regression as things that are being measured. And you can see the other person having a slightly lower rating, but still scored pretty decent, but in different areas. But this gives you some really good feedback on how you can improve, and also why you scored that way. I will give you a short demo of this platform. So if you go to the GRAPS platform, you type in your credentials, and it tries to figure out where you are and locates an AWS machine near you, spins it up. You go into a virtual machine that hosts the platform. Here you go. Speed it up a little bit. There we go, spinning up. We're going into a Linux box, and a wizard will be started in a few moments. So here we are. We're now in the wizard. So it says welcome. You're going to be measured. These are the areas that we're gonna measure you in, and it's going to ask you to test if the environment works as you expect. So it explains to you what the different things are again, how many tasks you're going to do. This person is asked to do 5 different tasks. And the next step is to check out the platform, pick one of the 2 available IDEs, IntelliJ or Eclipse. Who is using Eclipse here? One person. Okay. Most people are using IntelliJ, I think, nowadays. There you go. Well, you check out if you can work with it, if it all goes well. You run a few tests here, and if this all goes well, you go on, and then we go to the first task, and this is correcting a logical bug in the find function. So you get some explanation about what the task is. The idea is that there's a graph that holds a value in each node, and the function needs to check if every value is actually present in one of the nodes, the values 1 to 5. Pretty easy stuff. So you read this, you try to understand it, and if you're ready for it, you hit begin, and then you go to IntelliJ, and here we go. Now we need to find the bug. So we can run the unit test. You can see that we have an error. We cannot find all the 5 values. And now we go through the code really, really fast. So let me speed up a little bit. And what we're going to see is that there's a function that's not returning the right parameter. And we need to correct that and give back integer k. And now we rerun the test, and then we will see that the test goes well. And now we solved it, and now we can go on to the next test, next task. So we do this for 5 different tasks, and then we get a score, like you just saw on the previous slide. So at Open Value, we've been using this platform for a number of years, and I must honestly say that it was quite buggy in the beginning, and we helped Gunnar a bit improve the software. But we find that this software works, well, I would say really, really well, surprisingly well even. So we always ask somebody to take a test, and if somebody scores below a 4, that's for us a filter. But if they score like above 6, they're always really good. And this is really surprising because we only test like core Java skills. By the way, other languages can also be used with the platform, but we only use it for Java. If somebody scores higher than a 6 on this platform, they always know everything about front end, about cloud technologies, infrastructure. Well, maybe not everything, but a lot, at least enough for us. And we, well, regularly do those people a job offer. And we did a lot of tests already here, as you can see. And so I'm always a little bit surprised that you just take this online test. And by the way, there's a bit of manual grading in the task. It's not graded automatically, but most of it is. And then you already kind of know how the technical interview will go. And by the way, in our case, we do have like a 90-minute Q&A where we try to dig really deep in, well, where's your knowledge coming from? How well do you know certain concepts and so on? But it never really changes, well, what we are guessing based on the interview. So that's based on the test. So that's quite amazing. So switching gears a little bit, want to talk a bit more about certification. I mentioned this already, and well, certification is definitely not a great way to test programming skills, as I already argued. But wouldn't it be really nice that we can use, well, this platform that I just showed you in some kind of way that we can also like standardize this for programming languages so that you only need to take a test like one time in your career, or maybe a few times if you think that you progressed, and then just show that result to a company that you want to work for, or to a team that you want to work with. And then they say, oh, if you scored this well, we're definitely going to invite you at least for an interview. And they're not going to give you like those lengthy homework assignments. Wouldn't that be awesome? But this is something that we are trying to accomplish for Java with the FAANG community. So the FAANG community is a global Java community where a lot of people participate quite actively. There's a FAANG.io website where there's like 2 articles around Java subjects online every weekday. There's a podcast, and you can find the FAANG booth at many conferences as well. It's a great place also to ask any technical questions. And what we did is also start like a FAANG certification initiative here, basically using the insights from the Grasp platform and also the platform itself. There's an article online about this, and it turned out that there's a lot of enthusiasm for this, with over 80, well, community members, Java champions, other people who are involved in conferences, people who are involved in all kinds of open source projects. We had a discussion around the subject, would this be a really good idea to, well, try and promote amongst our community as a standard way to determine skill level. And people were, well, of course, not convinced straight away, but they were definitely interested in taking a look. And what we did with a work group, we created specific tasks for the Grasp platform. And these tasks should be the kind of tasks that measure things in the Java API that you want people to be proficient with. At least that's what the FAANG community thinks. We did like a poll for this. And we're currently in the beta phase, so we had quite a few people doing a test run now with these tasks to see if we feel comfortable with, well, saying that this is a great way to determine not only the skill level, but also specifically the Java skill level. So if you're curious and want to know more about this, let me know. Then you can do a test drive. So we're currently in the beta testing phase, and we'll be happy to share this with you. Okay, this is my last slide. Small recap. So coding is mostly about skills, and research actually shows how you can measure these skills. And why not also use this, well, for a more honest Java certification that you can also like reuse if you go and apply for a job somewhere, or maybe if you want to know what your skill level is and want to see if you progressed over time, and so on. This is it. I don't know if there are any questions.
Thank you, Roy. Round of applause, please. You got a woo. Any questions from the audience? Everyone here?
Do you have suggestions how to measure not only Java knowledge, but also some framework like Spring knowledge? Because I assume that's also important in a lot of roles, because pure Java these days are probably less important.
I 100% agree. One of the statements that I did is that the task should resemble your normal day job as much as possible. So most Java developers nowadays are definitely working with Spring. So having said that, like finding the bug example that you saw isn't necessarily a whole lot different in Spring, while you can of course come up with some specific things that are inherent to Spring. This could potentially be added. There's no way it could not be added, but it's just not available. So the platform is nowadays also compatible with Kotlin, for instance. So that's also something you can use. What we found again is that if somebody scores quite well on this test, and they're a Java developer, they normally know enough about Spring as well. You don't learn these Java coding skills by accident, and you probably worked with Spring then apparently already, and then therefore there's a correlation probably between your Java knowledge and your Spring knowledge. But it would be definitely a great add-on, I think.
Thank you. Any other questions from the audience? Okay, then we can go to the questions on Slido. The first one is, how do you assess if the person is a team player versus a lone wolf?
Yeah, so what I can do here is hide a bit behind the research. It didn't say really anything about this. What it did say is that skill level is an important predictor of how well somebody will perform in a team. But that doesn't necessarily mean that they're a good fit for a team. So there's of course other things also influencing that. So how I would assess that personally, well, yeah, I would just ask questions, of course. How well did you work together? And yeah, you probably, if you ask them about practical examples, you get some kind of idea. But it wasn't really something about this in the research that I looked at.
Yeah, but you can also do HR tests during the 90-minute.
Yeah, for sure. That's also a way to go. Yeah, makes sense.
The next question is, if 5 years of experience is not necessarily required to be a senior, How many years of experience is then a few?
Yeah, that's a good question. So 3 or 4, I would say. I think that's also what suggested. They couldn't put an exact number of it, just that the number of years of experience was not a really good predictor beyond the first few years. So yeah, it's somewhere between 2 and 5.
The next question is, for the Dunning-Kruger effect, does it also apply for women, that women rate themselves too high? That's a good question.
I, I don't know. I think there's not the what was being mentioned in the study. They didn't differentiate between men and women. That's all I know. So I guess it goes for both, for men and women then. Okay, this is really interesting. I will repeat for the rest of the audience that might not have heard this. So men tend to rate themselves 16% too high, and you said women 60, 60? 16, you're right, yeah. And women, how much lower? 9. So, but still a bit higher, but it's not as strong. Lower? Okay, so that's interesting. Should definitely look into that. The confidence gap. Okay, that's how it's called. Interesting.
Interesting, yeah. The next question. Lots of studies are 20 plus years old. IT has changed. Can we still use those results to have meaningful takeaways?
Well, Gunnar H. PhD was in 2015, so that's not too old, I would say. That's one thing. And the specific work that he put into it is all from the last 10, 15 years. Yes, there are a bunch of studies that I made references to that are way older. But a lot of the things mentioned in those studies are also like general concepts. I think the Lisp study does play a central role in his work. But if you look at the central claim of the study, that you can learn something about productivity of a developer in general in a certain language by looking how well somebody's able to solve problem A, B, and C, and that is going to say something about D, E, and F. It also sounds kind of logical, right? So I'm not definitely a science expert who can make the judgment call here, but I do think a lot of those takeaways still have some value.
We have time for just one more question, even though there are a lot more. So my suggestion is that every other question you have, you should ask Roy at the Ask Me Anything part. And I'm going to read one more. With the growing integration of LLMs in development, how should we adapt methods for measuring a software developer's abilities?
Yeah. So what we did at Open Value, we used, of course, we used ChatGPT to do the test, and you know what? It did quite well. So that was a bit disappointing. So yes, you can hack this test. That's something we learned. So I guess you can hack any test if you really want to. I mean, you can always ask somebody else to take a test for you if you have an online test. So in the end, is this really a bad thing? And if you want to be sure that this is not happening, well, maybe you want to ask somebody to come to your office location and you put your laptop there with the Krebs test on it, so you make sure that they're not accessing ChatGPT. So that would be an adaptation you can certainly apply. And I would, even though I'm really convinced about the value of this test, I would never only use the test. So I do recall we had a computer science teacher who scored like a 9 on this test. So it also comes back to the point about the Spring framework question. So we had high expectations of this person, but in the technical interview, it turned out he didn't knew a lot about Spring or about basically any other stuff than purely the Java language. So you never use, I would say, any test like this as the only selection criterion. So that's maybe something to take into account, that you use this as one of the things, I would say.
Okay, thank you.